So we'll start with A. Show W bar is also a root. First thing, we need to know that W is a root of Z cubed equals to 1. So is a root of Z cubed equals to 1. So this then tells me that W cubed also equals to 1. Correct? W cubed also equals to 1. Now we take the conjugate of both sides. If two complex numbers are equal, then you need to know that the conjugates are also equal. So let's rewrite this as W bar cubed equals to 1 plus 0i cubed. You'll understand why I wrote in a second. So now if you take the conjugate of this then becomes cubed, correct? Equals to 1 plus 0i, the conjugate of that is 1 minus 0i. So that just remains equals to 1. Therefore, we know that W is also a root. W bar is also, W bar is also a root of Z cubed equals to 1, because 1 equals to Z cubed. Hence, W bar is a root. So that's how you do A. We'll go on to B now. Relatively straightforward. Show that equal to 1. Now that we know the three roots of Z cubed minus 1, which is Z cubed equals to 1, the three roots of this is 1, W and W bar, right here. Correct? Rewrite this as Z cubed minus 1 equals to 0. Put B over here. Z cubed minus 1 equals to 0. Sum of roots. To understand sum of roots from polynomials, we can go, sum of roots is minus B upon A. Alpha plus beta plus gamma equals to negative B upon A. In this case, B is 0. A is just 1. 0 upon 1 is just 0. So this then gives me 1 plus W bar equals to 0. That's how you get B. It's relatively straightforward. Do C over here. 1 plus W squared equals to 0. Come back to this over here. We know that from earlier, we knew that W cubed also equals to 1. So we can go W cubed minus 1 equals to 0. Expand using that. Like this, we can go W, I'll just write it over here. We have W minus 1, W squared plus W plus 1 equals to 0. We can equate these separately because divide that, when you have a 0, you can equate them separately. So we go W minus 1 equals to 0, or W squared plus W plus 1 equals to 0. But since W is a non-real cube root of unity, this is your answer right here. Because that just gives you W equals to 1, which is real in this case. So this is your final answer for C right there. So yeah. Looking at example 5 now, it says, let alpha be a complex root of Z to the power of 5 plus 1 equals to 0. A. Show 1 minus alpha plus alpha squared minus alpha cubed plus alpha to the power of 4 equals to 0. Okay, we've got a subpart. Find a quadratic equation with roots, these roots over here. And then B, let alpha equal to cis pi on 5. Find cos pi on 5. So, let's start with A. Show that 1 minus alpha plus alpha squared, that equals to 0. From this, we can know that this also equals to alpha to the power of 5. Alpha to the power of 5 plus 1 equals to 0. We can rewrite this using something different. A geometric progression. Geometric progression theory This then becomes alpha plus 1. We have 1 minus alpha plus alpha squared minus alpha cubed plus alpha to the power of 4 equals to 0. Geometric progression, it talks about alternating between negative and positive after each variable. So if this was to the power of 6, we could have minus alpha to the power of 6, or minus alpha to the power of 5 in front of this right here. So it just keeps alternating between negative and positive right there. Now equate both sides, because we've got a product of 2. We can just divide both sides by each other, we get 0. So we get 2 solutions. So we get alpha plus 1 equals to 0, or this 1 minus alpha plus alpha squared minus alpha cubed plus alpha to the power of 4 equals to 0. We know that that gives us A right there. Let's go to B. Relatively straightforward question A. Now we go to B. B says, find quadratic equation with roots these. Okay. Coming back to this, we can rewrite this as minus alpha, B, minus alpha plus alpha squared minus alpha cubed plus alpha to the power of 4 equals to negative 1. Correct? That equals to negative 1. That's sum of roots equal to negative 1. Now we'll go product of roots. 4 roots, we've got alpha to the power of 4 minus alpha, brackets, alpha squared minus alpha cubed. Correct? Now we can expand this. Alpha to the power of 4 times alpha to the power of 2 is alpha to the power of 6. Sorry, 6. Alpha to the power of 6. Same thing. Multiply that and that. Oh, sorry, add that and that. We get minus 4 plus 3 is 7. Alpha to the power of 7. This and this. Minus alpha to the power of 3. This and this. Plus alpha to the power of 4. We can rewrite this as minus alpha cubed plus alpha to the power of 4 plus alpha to the power of 6 minus alpha to the power of 7. But we know that alpha to the power of 5 equals to negative 1 from earlier. Correct? So how can we change this? That's alpha to the power of 5 multiplied by alpha. So alpha to the power of 5 is negative 1. So we can rewrite this negative alpha cubed plus alpha to the power of 4 minus alpha. That's same thing. Alpha to the power of 5. Plus alpha minus alpha squared. Right here. We can rewrite this now. We can go alpha minus alpha squared plus alpha cubed minus alpha to the power of 4. Find a quadratic equation with roots of those right now. Yeah, so this then overall equals to negative 1. I believe. So therefore, our quadratic equation then equals to, we have z squared plus z minus 1 equals to 0. So that's the quadratic equation we get for this right here. So we go on to B now. Come back to B now. We can let cis equal to this alpha equals to cis pi on 5, find cos pi on 5. So cos pi on 5, we can come back to these two equations right here. So we'll start with this first one. We go alpha to the power of 4 minus alpha. Another way of writing this can be, we can go minus alpha to the power of -1 minus alpha in this case. Correct? So this then becomes minus brackets alpha bar minus alpha. But we already know what this equals to. This equals to cos 2 cos, because this is all real. If we expand this out, this all gives me a real value right here. So I can rewrite this as minus cis bar pi on 5 minus cis pi on 5. So this then, because we've got the minus sign here, that's all of this becomes real. So this then becomes 2 cos pi on 5. Correct? That equals to 2 cos pi on 5. Now we go on to this one right here. So this one right here tells me alpha squared minus alpha cubed equals to alpha squared. So we can rewrite this as plus alpha to the power of -3. Again, same thing. This all gives me a real value right here. This then becomes 2 cos 3 pi on 5, I believe. My bad, 2 pi on 5. 2 pi on 5. That then gives me 2 pi on 5. We can equate the original values of the quadratic we had found earlier, which is z squared plus z minus 1 equals to 0. We'd figured that out. We can solve for z, which then the two values that we get is z equals to 1 plus minus square root of 5 all upon 2, I believe is the answer that we get when we expand these two values. When we factorize this, so this then gives me, coming back to these two equations, 2 cos pi on 5 equals to the positive case in this case. So 1 plus square root of 5 upon 2, and 2 cos 2 pi on 5 equals to the negative case, 1 minus root 5 upon 2. So therefore the final answer we get for cos pi on 5 is equals to 1 plus root 5 all upon 4. So that is the final answer we get for this right here.